All right. Hello, everybody, and welcome to the stream. I hope everybody is doing well tonight. Tonight, we are picking up where we left off last night in our pretty massive journey of refactoring. And we're going to make a little bit more progress tonight towards that, I hope. And I can kind of start to see sort of the other side of the field, right? We put a lot of miles on the refactor tractor, but it's starting to come to an end, right? So we're almost there. We've got a few more things that we've got to tie up that we still have to restructure, but nothing too huge at this point, right? It's mostly trying to resolve references to things that we've already renamed and things like that, right? So that's kind of where we're at so far, and that's where we're going to pick up tonight. So that is what is on the roster. Kuju raiding with a party of 22. Thank you so much for the raid. Good evening. How are you guys doing? We actually just started here for tonight. What'd you get up to on stream? Thank you very much for the raid. Appreciate it. So what I'll do, I normally start things a little bit differently, but since we have some raiders, I will go ahead and stop and give a quick introduction as to what we're doing here, so that everybody is on board. Let's see. Good was working on the decal deferred rendering based indicator system for charging abilities. That sounds awesome. I wish I could have caught that actually, but real life gets in the way sometimes, right? But yeah, that sounds awesome. I may go watch the VOD for that, because decals is actually something we need to still put in the engine at some point. So, speaking of the engine, for those of you who are new to the channel, what we do here is we are building a game engine from scratch using C and Vulkan as our initial rendering backend. I say initial rendering backend because we plan on supporting multiple backends. It's been developed such that we can do that. And so we are going to be adding Metal to that list for Mac OS and eventually iPhone. And we are going to be adding DirectX to that as well for Windows, as well as eventually Xbox. And of course, we have Vulkan, which right now supports Mac, Windows, and Linux. Mac OS, of course, support on that is a little bit tricky because we have to go through MoltenVK, but those are the different backends that we support. And I should also mention that the entire thing has been done pretty much on camera, right? So we've started this project about 3 years ago, and it started off as a tutorial series and morphed into different formats over time, and eventually we landed on the live streaming format. And so we do simulcast to YouTube and to Twitch. So we have a website for this. It's called the Kohi Engine. So I'll drop a link there in the chat. And so KohiEngine.com is sort of the central hub, right? It's where you can find all the information about this. So the engine is completely open source. It is completely free. Free as in free and open source, but there will never be any sort of licensing fees of any kind. There will never be any royalties of any kind, ever. So it is available completely on GitHub. It is still very much under construction right now, so I would not necessarily attempt to use it to make a game just yet. We're probably about a month or so away from getting to the point where we can do that. We are in the middle of sort of a refactor effort at the moment, so unfortunately I can't show it running. However, I do have on the repo, I have a couple of screenshots here that show a few things in operation, right? So we've got a PBR-based lighting system with some basic shadow mapping and things of that nature. We have a very basic UI put together as well. And so all of this has been made from scratch on stream and is all available here. And yeah, there's a couple of other links here. We've got a Discord that's got a little over 900 people on it. And of course, we've got the GitHub links and Patreon if you want to support my work, yada yada. And then of course we have the Twitch stream here where I can see myself, indefinitely there in a hall of mirrors. So that is basically the intro, more or less, right? The engine itself is designed with a plugin architecture in mind. So most of the systems outside some of the core ones are plugins. The rendering system itself is a plugin. So the rendering backend, the Vulkan backend, is actually a plugin. The sound system is a plugin. The UI system is a plugin. Those things are not part of the engine core. And so that's kind of what we're doing in terms of that, right? Another example of that will be the physics system will also be a plugin, right? Okay, so let's see. The indicators work as decals until you leave the ground, and then they kind of rip off the ground. That sounds pretty cool. That's awesome. Gus Viola, hello. Welcome. Welcome to the stream. Hope you're all doing well tonight. RCW, good to see you. Smudge, good to see you as well. Welcome to the stream. So, what we are doing right now for the benefit of the raiders is we are in the middle of, as I said, a pretty big refactor. So, because we started this engine off in sort of a tutorial format, there were lots of things where we're just like, along the way, we're just like, we're going to put a pin in this, we'll come back to it. Some of the things were kind of architected in such a way where it kind of fit a tutorial format better than, you know, sort of the end runtime, right? So we're kind of fixing some of that stuff and resolving some of the technical debt that's stacked up over the last couple of years before we actually start developing our first game project with it. And so that is what we are in the middle of now. We've been at that for a little bit, but we are sort of nearing the end of that. I don't think we'll get there tonight, but we are getting towards the end of that. So we've done some pretty extensive refactoring within our Vulkan backend itself. And a lot of it now is just sort of going through and resolving some naming issues. We've moved some code around. We recently switched to use dynamic rendering for the Vulkan backend, which means that we did away with render passes and frame buffers, which simplified things for the most part. But it means that we did break some stuff, right? So that is kind of where we're at. We're just sort of working our way through that. So I hope all that makes sense. And once again, welcome everybody. Okay, so this is about where we left off last night. We just need to get sort of this this file compiling. And then we also we're looking into potentially getting away from having to include the uniform locations in our various texture maps when we are loading up materials. So if we can't do that here, I've got some other ideas about how we might actually tackle that problem. So we'll kind of see where we land on that and go from there. So with all that said, let's take a look at, you know what, actually, let's move this over a little bit. So I'm basically going through our Vulkan backend file now and just kind of fixing the errors as I find them. So we have channel count to format here. What is this expecting? So this just wants a channel count. So it looks like T, I'm guessing, doesn't exist, which is the texture. And that's because we have texture data. So our internal texture data, which is what the backend sort of keeps track of, that is what actually holds like our Vulkan images and things like that. Our render API specific stuff, right? So we do have a renderer front end and a renderer back end. The renderer front end is sort of all of the API agnostic stuff that the rest of the engine interacts with. And then we have the back end, which is all of the API specific stuff like Vulkan stuff. Let's see. Hello, do you know any engine that uses C as its main language? Well, this one, for one thing. But as far as any engine out there commercially, I don't know off the top of my head. And that was part of the reason I did this is to sort of take that challenge, right? So we're not really using object-oriented programming for the most part. We're kind of steering clear of that. We don't really use function overloading. We don't use most of what C++ actually provides. And so I was like, well, why am I using C++ then? Let's go ahead and use C, right? So I know that there are a lot of engines that used C in the past. IDTech was an example of that. That's probably the one that gave me the most inspiration for this was the older id Tech engines. They've since switched to sort of what I call a C++ Lite, which is C like C++, where they use very basic features of C++, but not all of it, right? So yeah, I hope that kind of, sort of, but not, I guess, answers your question. Eyeless42, good evening, hello. Let's see. I see your YouTube shorts. All good, but now, brother, triple thumbs up. I appreciate that. Yeah, I'm glad the YouTube shorts seem to be making their rounds lately, which is kind of cool. Saw your YouTube series because I was looking at something that uses C because I love working with it, but I never came across one besides yours. And that was one of the reasons I started this, right? Is because I started doing a little bit of research out there on like, hey, who's written a game engine in C lately? And the answer was basically nobody, right? Outside of like hobbyist engines. And so that was one of the reasons I took the challenge, right? And the cool thing about C is if at some point we wanted to switch over to C++, that would be very easy to do. And in fact, we could write some of our libraries in C++ if we wanted to or had to for some reason. So C makes that very easy to do. Let's see. I'm learning C for my software engineering degree. Happy to see people using it still. Yeah, I agree. That's awesome. I think C is a very valuable language to learn, even if you don't use it every day, because it really teaches you how things work under the hood, and I think that's super valuable. Okay, so I don't believe in the texture data. I don't think the images themselves have... Do they have... They have format, but I don't think they have channel count. Oh, but wait a minute. If we're resizing a texture, we actually don't need to do this anymore, actually. This is something that sort of bled over to the back end that really should have been more of a front end thing, but actually if we think about it, so if we're resizing an image, we already have an internal Vulkan image, right? We're actually looping through these things. Then we have this format here, right? So we're determining the format after we destroy this guy, which actually is not going to be the right way to do it. So what we should actually do is before we destroy the image, we'll say image format, and we'll just grab the image and save off the format because it's there, right? And that'll solve that issue. Let's see, MIP levels. So do we have MIP levels in? We do have MIP levels. Okay, so we can use the image MIP levels for that. So I guess, let's see. Let's do U32 MIP levels. We're just going to save that off too before we destroy it, right? So we'll say image MIP levels. Right? And then that way we can just do that. And then we can say MIP levels here. I'm not sure why we were setting the front textures MIP levels. I guess if we're resizing the image, this number could change. Theoretically. So that may be a problem. But I don't think the front end needs to know about that. So we may actually wind up eliminating that from the front end. We'll see. What is this bleating about? Kfloor and klog do not exist. Okay, so those are our specific floor and log functions. I guess we are missing the math include. Strangely enough. It's right there. Okay. So that one's fixed. Let's see. So we have texture type. Vulkan image create. So I'm thinking that probably is also... do we have that saved off? I don't know if we actually have that saved off. So that one may be a bit of an issue. Okay. And I think that might actually be more of an issue because if we go and look at this function here, let's actually Vulkan image C, and let's do creates. If we take a look at this guy, Mortalo, thank you for the follow. Appreciate that. C is fun once you understand the memory. It just kicks in. Everything is just data in memory. Exactly. Yep. All you're doing is manipulating bits. It's confusing when my brain thinks in JavaScript, and a lot of solutions there just don't apply the same in C. 100% true on that. Definitely true. Okay, so what are we doing with type at this level? So we're just determining the underlying image type. Okay. So out image, we could actually just save that off, I guess, right? We're not actually doing that, but if we wanted to, we could very easily do that. And we probably should, just for the sake of, you know, image recreation, right? We could cache it at this level, and then we don't have to sort of recalculate it and run through a whole bunch of stuff. Let's see. Gus Viola, thank you for the follow. Appreciate that. Never understood JavaScript or any web thing. I like it simple and with defined behavior. 100% agreed on that too. I mean, JavaScript has its place, obviously, right? I don't like using it, but I will when I have to. So, all right. So, what are the other things? So we have here MIP levels. We can keep there. Name. What do we need name for? I'm assuming that's probably just image. No, we probably use that for the underlying image, don't we? The underlying image name. Okay. Here's the create image. We do have... We take a copy of the name, which I don't know why we're doing that here. Here we go. That's the debug object name. That's why we need it. Okay. So we do need to pass the name there. I don't think, though... I don't think we have that at this level, which is kind of annoying. So we may have to rethink this a little bit. Let's see, what else do we have? We have array size that we need to pick out of there. We have type, and we have name. So we need to cache some of these things at least, so that when we go to resize it, we don't have to recalculate all that stuff. Otherwise, when we go to resize it, we're going to have to pass it in here, which is not ideal. You really hated JavaScript that you spent a couple months looking for some way to do web in C, and it was really frustrating. Yeah, I can understand that. It's just not the same, right? And it can't be. I mean, you really don't want to expose direct manipulation of memory to the web anyway. You won't get defined behavior with JavaScript. It will interpret what you wrote as much as possible instead of giving you an error. That's actually not always true. So there are plenty of things in JavaScript, especially if you start dealing with like WebGL, that depend on the underlying browser implementation and driver level stuff that actually has bugs in it. I've run into a lot of bugs with things not working the way that they should in JavaScript, especially when dealing with GPU stuff. So yeah, JavaScript is definitely it definitely does not prevent you from getting undefined behavior for sure. All right. I wonder if the YouTube side is up. Because I'm not actually seeing it over here, which is a little bit strange. I think the YouTube side might not be actually working. I'm not sure. I can't see any chat or anything either. All right, so that might be broken tonight. Sweet. Okay, so how do we want to handle this? So what we're doing, now that I think about this, actually, if we think about what we're doing here, we're doing a resize of a texture, right? And we're tearing down the old texture and standing up a new one, requiring all brand new properties for the whole thing. That seems like, we might be able to actually do something a little bit better than that, right? What if ultimately that's what we're going to do anyways, but what if we had like an alternate version of this where we had like a Vulkan image recreate, for example, where we just maybe cached this create info and just pass that in instead, right? Because if we were to cache the create info, then we wouldn't need all this stuff, right? Because the create info is already filled out and ultimately gets passed here. And technically the same would be true for the allocate info, and actually the image view as well. So maybe instead of sort of keeping all these properties like this, maybe the real correct way to do this would just be to store off the creation info. And for something like a resize operation, we could just modify the extents, right? Maybe that's the way to go. Or theoretically, technically this is figuring out a whole bunch of things based off of all this stuff that we pass here, but I don't know that all this is necessary all the time. Now that I've been using lots of C, I find myself rolling my own functionality rather than using the JS-Lang built-ins. I do that all the time too, especially with libraries out there, right? Especially when you have libraries like LeftPad. I think it's ridiculous what people use libraries for JavaScript. That ecosystem is a mess as a result. It's just some of the things that it's like, you really have a library for left padding a string? Come on. Or any other language features, as a matter of fact. C habits showing up in my other coding project. Yep, 100%. I find myself steering away from OOP too when I do like web work. That's the point, thinking about what you're doing instead of just getting something ready. Yep. 10 megabytes of memory use is considered sane. Yeah. Maybe if you're loading a texture, right? It's just a simple web app. Yeah. Yeah, the whole meme about node modules, right? Let me see if I can find it real fast. So we have, here we go. So this one, heaviest objects in the universe, right? We have the sun, the neutron star, the black hole, and then node modules is all the way down here. So, yeah. If you've ever done any sort of web dev, you know exactly what I mean. All right. Anyway, I digress. What you're doing is open source? Yes, it is. I wanted to learn Vulkan, but I don't know any C++, and all the examples were in that. So where did you start with Vulkan? Any good source? I have a couple, actually. So you're probably not going to like my main answer to it, but I'm going to give it anyway. The Vulkan spec. Read it again, implement a renderer, read it again, implement a renderer, read it again, throw out your renderer, read it again, make a new renderer, throw it out, right? I've read the Vulkan spec probably a few dozen times at this point. It's painful, it's dry, it sucks to read, but it's the only way you're really going to truly understand it. That being said, you're talking about also learning C++ and all of that other stuff. There are a few resources out there that will help you with it. But like any other tutorial, they generally only kind of scratch the surface, right? So there's something out there called Vulkan Tutorial that you could use. There is also, what is it? Vulkan... I'm trying to remember what the name of it is. vulkanguide.dev. So there's this guy, right? vkguide.dev. This one's decent. It's got some decent stuff in here. So you've got that one. You have let me pull it up here. You have this guy, which has kind of been around for a while, right? So this is an okay place to start. This gives you some high level stuff, but these things are no replacement for actually reading the spec and understanding it, right? There's also, let me see. Let me find it here. There's also this GitHub repo by Sasha Willems, which is a pretty well-known graphics developer, right? He has made a whole bunch of examples on how to do stuff in Vulkan. And these are actual code examples that are out there. Now, these are all C++. He's got his own little framework in there, right? And these are examples that are tailored to specific features, right? So none of these things are going to show you how to make a game engine, right? These are only really going to show you how to use different features of Vulkan and get a basic renderer going. A lot of these concepts will get you started, but you're really going to have to research and start kind of doing this stuff on your own, or watch a series like this one to really understand how to make a full engine out of that. But yeah, a lot of people use C++ for Vulkan, which is kind of crazy because Vulkan is a C API. There is a C++ one too, but predominantly it's a C API. So what we've done here is all in C, but it changes a lot too. So let's see. Maybe you should just roll your own JavaScript compiler. Oh, geez. You aren't the only one that's thought of doing that, by the way, but I quickly backed away from that. You don't want to learn CPP, you just want to implement it in C. So, and that's fine, right? A lot of examples in C++ can be translated to C, so that's okay. If you know C well enough, you can generally look at C++ and kind of translate it, right? And kind of work around the different features that they're using and just kind of subtract that stuff out, right? With the spec, you got stuck in one place from the beginning and couldn't find any non-CPP examples. That's fair, right? So I would say, there are, this repo is a working example of it, right? So if we go to, let's see, do I still have it open? So if you go to this repo and you go to the main branch right now, it's probably the one you're going to want to look at. 0.7 and feature reorg are what I'm working on right now. So these are in progress. You're probably not going to want to look at those. They may not build. But the main branch should build. If not, you can use 0.6 as well. But there is, under Vulkan Renderer, you have all of the Vulkan specific stuff, right? So Vulkan backend is going to contain a lot of, the samples that you may be looking for. And then there's also, device, image, pipeline. There's some of these things are swapped out or broken out, right? We have ads. So for those of you who are new to the stream, I'd like to pause the stream whenever ads come up on Twitch, which is once every 30 minutes for up to 90 seconds, depending on region and locale. So I'd like to just pause the stream so that nobody misses any content, right? So that's what we're doing here. We have a timer on the screen, so you guys know exactly when we're coming back. I'm just going to take a second and hydrate. I would suggest you guys do the same. Got about 20 seconds left. All right. What ads? Yeah, so not everybody gets them. So depending on region or locale or what platform you're on even, you may or may not get ads. So some people get them, some people don't. There can be up to 90 seconds of them, so I like to just pause the stream whenever those come up so that nobody misses anything, right? Because it is a programming stream. We're explaining kind of technical stuff here. And it would suck to have that, blocked by a full screen ad. So we like to just even the playing field on that. Ruby, thank you for the follow, by the way. I appreciate that. Okay, so I think instead of doing this sort of destroy and create, we might do like a recreate. Where we can cache the create info and maybe even cache the view info. And then once we run through this sort of creation, right, we can use the recreate and just pass those through and use those instead, right? And we don't have to run through all this logic again. I think that makes sense. So we're going to do that. And that will also let us avoid having to duplicate all of these properties in the actual sort of image backend itself, right? So we might even be able to simplify this Vulkan image structure as a result. So we'll see where we wind up on that. So let's do a. Let's take this guy. Right, and for now, I'm going to duplicate it. Let's put it... I guess let's put it below... Yeah, let's put it below the view creation, which looks like we've got some issues there to solve, too. Not a big deal. All right, so that's for transitioning image layouts. So yeah, we can put it right here. We're going to call this, we're going to say Vulkan image. recreate is what I'm going to call it for now. I'm not sold on that name yet, but we'll see. And instead, we are going to take well, we need the context. We're going to take vk image view create info. And actually, let's go ahead and take a constant pointer to that. So that way we don't have to copy over that entire structure, right? So we'll take that. We'll also take a constant pointer to a vk image create info. Oops, those should be backwards actually. Create info. And this should be view create info, and then we'll swap those. So we need that, and then what other, I think there was 2 more structures we needed. VK memory allocate info, and which actually we probably don't need to save that off actually, because that is going to vary when we recreate the image. So we're not going to save that one off. The allocation, the binding, that's fine. So actually, those are probably the only 2 things that we need, I think. So, so what we'll do is we'll take those 2, and we'll take all of this other stuff. Do we want name? Probably ought to take a name. Right. And since we're saying recreate, we're not going to say out image on this guy. We are going to move him up here. And we'll end the function's parameters there. Right. So we can eliminate a lot of these checks, right? So we don't need to copy the parameters. Our creation info is all good to go, right? We don't need that, right? Because we already have that, we're passing that in. So we can say here for our create image, this is going to be, you know what? Let's call this image create info, right? But since that's a pointer, we're not going to take, oh, wait a minute. Oh, it's not a pointer. It needs to be a pointer. There we go. So context allocator, out image handle. So let's rename out image. We're just going to call that image. Right. Okay. So we create the new image. We probably ought to destroy the old image, I'm thinking, and release the memory. But we'll do the creation first, and then we'll go back and do the destruction afterwards. So set the debug object name. So this is going to be just going to be that. Oh, the image name. The image name would already have been cached, actually. We do keep a copy of that, so we actually don't even need the name. Right? Let's see. So we need to get the requirements, right? So we're going to get the requirements for the image itself. We will pass it the memory requirements, handle, all that good stuff. Okay, so that should be fine. Memory type, we should not have to requery for that. But I suppose we will anyway. I suppose it could change, right? So we have memory flags. Didn't we actually save that off somewhere? image create info flags. Let's see, where was... Did we have memory property flags here? So we should probably, because I don't think we're actually... Oh, yep, we do have memory flags here. Okay. So we're storing that as well. Let's see. So this is really just image memory flags. Okay, memory allocate info. So this is going to be the memory requirements that we already keep on the image itself. Then we allocate the memory, obviously storing that in out image memory. So that's just going to be image. If we have a name, then we do the debug name thing. Okay. We bind the memory. So again, that's just going to use the image handles itself. Configurable memory offset. I can't think of why I would need that, but I'll leave it there anyway. Okay, so the next thing that we have here is whether or not we are dealing with device local memory. And so this is basically only for our memory reporting. So what this kallocate report is basically faking a memory allocation for a particular class of memory. For our when we go ahead and print out our memory usage statistics, this is how we report what we're using as far as the GPU is concerned, right? So if we're using device local memory, that means we're using GPU memory. Then we go ahead and we report that, right? So we say if the memory flags are using device local memory, then we're going to report that as GPU local. Otherwise, it's going to be tagged as like Vulkan usage, which is CPU Vulkan usage, right? Create view. So we don't have a create view Boolean here, but what we can check is we can say if view create info exists, right? Because that's a pointer. If that exists, then we're going to create the view, right? So we'll say image view. Let's see, we have image view create. All right, so this is where it gets a little bit. So instead of calling Vulkan image view create, we're actually going to call what that function calls inline. So if we take a look at this guy, we essentially construct a view create info out of that. And then call vk create image view here, right? And we also assign a debug object name to that. So we're essentially just going to do the same thing. We're just going to do it inline. Before we do, though, expression is not assignable. So we should probably... Do we have... We're not storing this anywhere. So this needs to change a little bit. Let's turn this into a pointer, right? And we're going to say this is equal to the address of image. Oh, you know what? I'm not going to change this function for right now. And I'll explain why in a minute. It looks like here we have some arrow functions that should just be dots. Right, so we'll just change those. And then what is this? out sub-resource range. That's already that. So I think we just need to get rid of that. Right. Okay. And then out create view info. Out view create info. So is this the creation info that we're supposed to be passing? Yes. Okay. So this should just be view create info, but it should be the address of that. All right. So that's fixed. And then that should be all fixed, right? Okay. So what we're going to do is we're going to take this, all of this, including that bit. And instead of calling this, we're going to do this inline, right? Oh, that's right. We have to handle this for MIP mapping too, which kind of sucks. I wonder if I should come up with a alternate version of that function too that just takes in the configuration and does the thing. But that seems kind of pointless too. You just do it in line. Okay, so if we're doing Vulkan image recreate, in Vulkan create, we should probably be storing these things off. And then we should be able to just use those inline here to actually call this. I think that makes sense. Okay. Bright Programmer, how's it going? Good to see you. For 2D games or isometric, does Vulkan provide more pros than SDL? So you're talking about two different things, actually. So SDL is a platform layer, right? It provides keyboard input, it provides your windowing, it provides sound, things like that. It does also have a rendering engine, and you can program it using OpenGL and Vulkan if you want to do that. And I think it also has its own sort of proprietary API that you can use as well. It depends, I'll say it depends on the scope of what you're doing, right? If it's a very simple game and you don't need a lot of advanced rendering effects, you probably don't need Vulkan, right? If you're doing, you know, especially if it's like a simple 2D game, like a tile-based game or something like that, like you probably don't need to use Vulkan for all of that. You know, just straight up SDL will more than likely cover your bases, right? It's a pretty good library. It's big, but it works well. I've used it in the past. So for 2D games, you know, unless you really want to if you're looking to like learn OpenGL and or Vulkan, then that's cool. But it really, like I said, it depends on what you're trying to make. For isometric games, there's a couple ways to skin that cat, right? So the isometric games can be 2D isometric, or they can be 3D isometric, or they can be a mix of the two. And I would say depending on how you're handling the rendering of that makes a huge difference. If you're doing 2D isometric, where everything's like just sort of flat textures, you know, sort of like a 2D tile-based game, but it's isometric in perspective, then you don't really need anything fancy for that. But if you're doing like a 3D style isometric game like Diablo or something, then you are going to need, you know, a little bit more advanced rendering techniques for that to handle lighting and to make it look good, right? So the requirements of what you're making vastly change what technology stack you should use. And there's pros and cons in both directions depending on what you're doing. So unfortunately, that means there's no one-size-fits-all solution, but that's the way it goes, right? Games aren't one-size-fits-all. They have lots of different things that, you know, that vary between them. Okay. So I'm going to put this here just for a second, but I'm going to comment it. And let's actually go and look at So this Vulkan image view create is called in a few places. We have our logic here for creating an image, right? And this kind of goes through creating the image. The image can be layered, which means that it can have multiple multiple images in one. Think of it like an overhead projector or something like that, or Photoshop layers, right? I just dated myself saying overhead projector. Half of you guys probably don't even know what the hell that is. But anyway, think of it like Photoshop image layers, right? So a layered image has a set of image data per layer, right? And so typically with those, you'll have sort of one view for the entire set of those. And then you may have one view per layer as well. And it really depends on how you're using them and what you're doing with them. But generally speaking, if you have a layered image, you'll have sort of that kind of setup, right? And so because of that, what we have here is when we're creating the image, we say, well, if we're creating views to go along with it, which we aren't always, then we do create that sort of single view that encapsulates all layers. And then if our layer count is greater than 1, meaning we essentially have a layered image, right? Then we loop through and we create one of those per layer, right? And so we essentially call this Vulkan view, image view create for that. Which this, makes this kind of nice and neat and compact here for doing this. But the problem with this is we are not caching this, right? So when we go to recreate this or resize it, we don't have it cached, which is suboptimal, right? So what I'm thinking we should probably do is we actually have the out image here, the created image has a view, right? And it also has a layer views array where we store the image views in that if we have a layered image, right? So we only actually allocate this in the event that we have a layered image. So what I'm thinking is we probably just store the view creation info right next to the view at this level. And then if we have a layered image, we also create an array of the create infos for those views and store it next to it in a similar fashion. And then when we go to recreate that image, we can recreate its views, essentially doing the same thing. So that's the way I'm going to tackle this, I think. It's what makes the most sense to me. So to do that, let's take a look first at the view, right? So we have a couple of things here, actually. So we're storing a couple things here. We have the image view, and we also have the sub-resource range, which we are storing. And then we also have the image views for the layer views, and then the sub-resource ranges for that. So we're actually pretty close on this. So what I'm going to do is do vk image create info. And we're going to say image view create info. Well, actually, no, we need both. Image view create info. Yes, and this is going to be view create info. Right, so we'll cache that. Did we actually add? I don't think we did. No. So we'll go through here and we'll do vk image create info as well. And we'll store this. Whoops. We'll call this image create info. And I guess we'll store this. We'll store this separate from the views, right? We'll just kind of put it here. Right, so we'll say brief the image creation info. Right, so we'll cache that. We'll cache these. Then we also need to do the same thing for the layers, right? So we'll put that in here. We'll turn this into a pointer. And we'll say layer view create infos, right? And that should give us everything we need to do. And, we store things like the memory requirements, the property flags, all that crap, the format. And I'm actually hoping that means we can actually get rid of this width, height, layer count, all that stuff. We'll probably need to hold on to the name. But I'm hoping we can actually get rid of these other properties, right? And not cache those at this level. So we'll see. So what we'll do here, when we do, I wonder, I think the only thing that we use the create view for is the swap chain images otherwise, I think. Vulkan image, view create. Oh, do we only really use it in here? Maybe I'll get rid of that then. We don't actually ever call it outside this file. Maybe it's time to simplify this a little bit then. Okay. Maybe we just do this in line. I mean, that kind of sucks though, I feel like. But I feel like it's a lot more explicit if we just do it in line. Deciding. Thank you for answering my question. Have to go to sleep. Hope to watch another stream. Awesome. Well, I appreciate you being here. Yeah, and we'll see you next time. Go get some rest. All right. So this view create literally just does this stuff. So it looks like we're literally just taking in the properties of this and jamming them straight into here. And then calling this and then doing this. I feel like that's not even worth the function call. I feel like we could just do that in line. So I thought in our swap chain though, let me check something before I... Yeah, our swap chains actually do this manually. In line. I'm going to do that here. I'm going to do the same thing here. There's no reason to have this function. All it's doing is just passing through all the stuff into a structure that we have to create anyways. And since we're going to cache the structure, there's literally no point in doing this. So let's take this view creates. And let's see, there's 4 instances of this. Right, so this is in image creates. There's 2 instances of it. That's the actual function itself. And then recreate has it, which we are working our way through. So in create, I guess, is the first place that we're going to, sort of modify this. So let's just do this here, and we'll say view create info. Let's do out image view create info s type. equals that, right? And we're just going to kind of fill it out that way. I think that makes way more sense because we're both creating the creation info that we're going to use and caching it off at the same time. So here I'll just do, out image view create info dot. And this is going to be out image. Let's see, Vulkan view types. Vulkan view types are ads. View some ads at the moment. Got to pay the Bezos, right? So we've got about 90 seconds of ads, and then we will continue on the other side. I didn't anticipate that this section needed refactoring too, but I suppose it makes sense that it does. Got about 30 seconds left on ads. All right, and ads are dead. Okay, so our Vulkan view types, where did that come from? Oh, that's this. Okay, this is a lookup table. That should be towards the top of the file. So let's do that. That's why that wasn't there. And then we have the sub-resource range, which is something that we need to cache off separately, but also have it be part of this view create info. So I think it was under out image view sub-resource range. Okay, so let's do out image view sub-resource range dot. And we should be able to now just do that. And then we can do out image view create info is equal to out image view sub-resource range dot. Oh wait, we don't actually need, yeah, we just need that. Okay, so view create info sub-resource range is now equal to this thing we just created here. So we sort of split this up, and this is because we actually need this portion of the struct separately for other operations that we do down the road, separate from the create info, which is why we do it that way. So aspect flags, we have here, so we have view aspect flags, right? So we'll just change that. Base map level, just hard-coded 0, always will be. We have image MIP levels, right? So I guess that's kind of the way I guess we have to just do out image, mip levels. All right, so the layer index. So we say if that's less than 0, then we use the layer count, otherwise we use 1. So when we're creating this one, let's see, what was we have layer count, then we have layer index, right? So it's context, type, count, then index. 1, 2, 3, 4. So index is -1, right? So in this case, we are less than 0, so we're going to use layer count. I think that makes sense. Okay. And then base array layer, if the layer index is less than 0, then we use 0. So it was -1 in this case, so we're going to use 0. Otherwise, we'd use layer index, right? So essentially what this is saying is this is the view that encapsulates all of our layers, whether we just have one layer or multiple layers, right? And base mip level is the first mip level, base array layer is the first array layer, and then we do it for the layer count, right? Which if we have 1, then it's 1. If we have 6, like for a cube map, then it'll be 6, right? So this one always kind of works the same, and then the ones down here work a little bit differently for the other layers. So I think that is good for that. We have view create info. So this is going to be out image view create info. And then we have out view here, which is going to be out image view. Probably need the address of that. Yes. Okay. So we filled that out. We've cached it at the same time. And then we go ahead and we create the image view. Now let's create the debug name for it. So in this case, it is out image name. And the layer index, in our case, we were saying was 1, or was 0 rather, right? Let me think about that. Yeah, base array layer is 0. Yes, so 0. Okay, and then our out view is going to be out image dot view. So that's what it's associated with, right? And we're also using, so this was something, I don't remember if I've mentioned this or not, but we sort of had this string format function that's a little bit unsafe. And you can see here that it's deprecated. And the reason for that is because using this can actually cause a buffer overflow if you're not careful. So I deprecated it and created a safe version of it. I sort of renamed the old version of it to unsafe and replaced that across the whole code base. And instead, instead of using this, let's use the safe version, right? Which I think out image name, I believe, is just a character pointer anyway. So the new version of this is actually going to wind up being out image name equals string format, and we want that version of it. So we enter the format string, which is here, and we want all of the parameters that are after it, right? So we'll just copy those, paste those here, right? And so actually this winds up being a little bit easier to use as well. So the way that this works under the hood is this dynamically allocates the memory for the string, right? So it figures out how big it needs to be, allocates enough memory for that, and then returns you that new string. So it's a lot safer to work with, and it's actually a better interface to work with as well. So we're going to swap that out to use that as well. So we actually don't, in this case, we can actually just use out image name. Now, do we want to do that though? Let me think about this for a second. So we actually don't want to store this in out image name, actually. We actually need a formatted, yeah, we need formatted name, right? And then this needs to be formatted name. We don't want to overwrite the name, right? We just want to use it as is here. And so what we can do is this dynamically allocates memory now, right? Which is fine because like we're loading stuff. I'm not really too worried about that from a performance perspective, because this will only ever happen in debug anyway. We're going to ensure that in just a second. So we can also do a string free, and we'll do formatted name. Right, so we'll clean that up. This set debug object name is only actually expanded on if we are in debug. Otherwise, it becomes a no op, right? So what we can do is if kdebug, I think it was, or is it just, did I define a symbol for that? I can't remember. Let's just use the underscore version of it for now. Right, so we have all of this only happens in debug builds, right? And the reason for that is because, you know, we can crank the thing up in RenderDoc, and we actually have the resource named in RenderDoc when we actually look at it for doing this, right? So we have that. That is that one. And then the next thing we need to do is the same thing for the layers, which thankfully we can actually reuse a lot of this stuff, right? So we can do away with that call to that, right? And out image view equals 0. Yeah, I'm okay with that for right now. So we'll take this whole section here, and we'll come down here, and let's see, we'll do right in here is actually where we need to put this, and we'll scroll this up a little bit, more. Okay. And what we're aiming to replace is this sort of function that's down here, right? So let's see. We need to look at view create one more time. So the only thing that we really have to be concerned about is these two guys, right? So layer count and base array layer. So I'm actually just going to copy these real quick so I have the logic handy. And I'm going to put those right here for the time being, right? And we know they're wrong, that's fine. But we can just kind of look at the parameters that we're doing here and figure out what we need to do. So the view type is actually just going to be view type, right? Or is that not? Cannot convert from texture type. Wait a minute. So we have view type as a texture type? That doesn't make any sense. Oh, it is actually though. That's interesting. So what are we doing here for the Vulkan view types? Okay, so view type is getting passed through there. Right. Okay. So what this actually needs to be is that view type. Right? So we have the view type there. The format should be the same thing. The view aspect flags should be just the same thing. The base MIP level should be 0. Level count should be the same thing. Layer count. So layer count, if the layer index is less than 0, which is not, let's see, we use 1 for here, right? So we do 1 layer at a time. And then our base array layer is going to be the layer index, right? So we have, let's see, I is going to be our layer index, right? That's our sort of loop here. So we'll set that. That means we can get rid of those. Okay, so view create info. This is going to be stored. Oh, we need to actually modify this a little bit too. Let's create a convenience pointer here. We'll say vk view image view create info pointer, and we're going to say view create info, right? And that's going to be equal to the address of out image level or layer view create infos sub I, right? And so that means that we can go through do that and do, oops, yes, wait, out image, yeah, this has to be something different. So this is going to be, we're going to cut this here. And then this view create info is a pointer type now, so we'll fix that. Same down here, right? And this is going to be, we'll take a convenience pointer also. We'll say vk image sub resource range, and we'll say view, whoops, pointer, view sub resource range equals the address of out image layer view sub resource ranges sub I, right? And now this becomes arrow operators all the way down, and we can do, oops, view sub-resource range, and we want to dereference that guy. Okay, so we set that up, right? We cache that off. Then we do, let's see, view create info. So that's already a pointer. So we've got that. Allocator, out image view. Okay, so that's going to be layer views sub I, right? So we want the address of that. Then create the view. The formatted name. We should probably change this string format to view layer, right? just so it's pretty explicit as to what it is. And then we use the name for the first part of that. We use I for the second part of that. And then we set the out image layer views sub I to be associated with that name. Clean that up, and that should be good. Get rid of that. All right, so by doing this, we essentially are able to cache these two structures in the array at the same time as we're using it as the actual info to create this thing. We'll need to also come up here and do the creation of the array. So that's going to be layer create infos, and that's going to be vk image create info times layer count, right? So we got that. I think that might be it for this guy. Yeah, I think that might be it. Okay. We probably also need to look at our destroy. So we destroy our image views, and we're freeing our arrays here. We're not freeing the new ones that we added, right? Or the new one that we added. So we need to put that in here. That needs to be layer view create infos. And we'll zero that out and then change this to size of vk image create info layer count, right? So we'll clean up that memory. All right. So that should be good to go. And now that we have all that cached in our recreate actually becomes much simpler. Right, so we sort of handle the complexity inline here. And then I think we can actually get away without most of this stuff in the recreate, right? So in the recreate, we don't need to create this view create info, right? Actually, wait a minute. The view create is only in 2 places now. We're about to nuke those. So let's see. So we create the base image using the image create info that we passed in. Now, if we resize this, we would either need to set the new dimensions here. I think that makes sense. If we're calling recreate, we should update this structure with that. Right, we shouldn't change it in here, right? Let's keep it constant. So we create the image. We set up the debug object name, which at this point is just the image name, which I'm fine with. Okay, we get the requirements, which is already cached. What do we need? Is the memory type actually needed? Yeah, I guess it is. So we'll have to do this as well. So we allocate the memory, we bind the image memory, we report that. And then if we create the view, we don't have to do any of this stuff. all we have to do is, let's see, view create info. And then do image view address of. The view create info is actually already a pointer, so that doesn't need to be the address of. So we create that. We can do the formatted name, so we'll have to follow the same pattern that we did further up. So we'll do character pointer formatted name equals, and then we'll do a string format. We'll get rid of that. We'll take in the format string, image name, layer index. So the layer index in this case is going to be 0. And then we set image view. Don't need to dereference that, and we'll use formatted name. We'll also say if def debug, or if, I guess, yeah, we'll do if def, and then endf. Right, so that only happens there. Then we'll do a string free formatted name. Right, just makes that a little bit easier. So we create that view, and then now we actually need to examine like the actual layer count, right? And this is where we sort of loop through that. So we're not going to have to handle any of this reallocation, right? We're going to have those arrays of things. We're going to leave those alone. So the next thing we're going to need to do here is we actually have let me think about this for a second. We actually don't need these things. We can get those from the image itself. So let's actually do that. Right, we actually don't need that. We can say image, whoops, not view create info. Was it image create info? Yeah. And we do need the address of that, right? Let's use what's already on the image. So this all should be good. And then we can do, so to create the view, how do we then determine if we're going to create the view? So we have here in this case, we actually literally say whether or not we want to create the view. But when we're recreating, we don't have this property, right? We don't have that cached, which I suppose we probably should, as much as I don't want to. Yeah. All right, so we will do I guess we could say has view, has views, view, right? And then we'll say out image has view equals create view, right? And then down, by the time we get down here, we can just say image has view, right? And then we can create the view using view create info. We'll need the address of that, right? Image view. Create the debug name. Layer count. Do we have? We do have ads. So there is that. I feel like we just had an ad break. I guess time's flying tonight. Yeah, it really is flying, actually. We've already been on for an hour and a half. So we've got about a minute left. And then we'll be back. We got about a little over 30 seconds left. Taman, how's it going? Good to see you. I'm glad you were able to make it. How are you doing tonight? All right. Almost done with ads. Doing fine. That's good. All right, ads are dead. You came late tonight because you're actually watching a Kohi video. That's awesome. Episode 22. Well, that's pretty sweet. How is that going for you? Hopefully well. Okay, so we have layer count. Did we cache that anywhere? I think we can actually extract that from, yes, the sub resource range has it. So we can actually extract it from there. Let's grab this. So let's do U32 layer count equals that, right? Now view type. So okay, I don't think we don't need to do this. I think all we actually really need to do is this, right? And just replace this with layer view create info sub I, and then layer views sub I. That should be it, right? We just create our views per layer. And we only want to do that for layered images where that count is greater than 1. All right, so as you can see, since we cache that information, when we go to recreate this, it becomes a lot simpler, right? And there are arguments that we could make here that maybe some of this could actually even be simplified even further, potentially, right? Okay, so we have a new memory type, memory allocate info. I don't think the image let's see, we have memory requirements, right? So that's our memory requirements that we have. That's going to have to be requeried every time. If we're recreating, we're going to have to redo that. That's fine. All right, so we have this recreate, right? But all this is doing right now is creating based off of the create infos we already have. We actually need to release the old versions of these things first. The old images views first. Then recreate, create new. So in this case, we're going to do vk destroy image, right? So that's going to be context device, logical device. The image is going to be image handle. And the allocation callbacks is going to be context allocator. Right, so we destroy the old image. Then we vk free memory, right? Context device, logical device. The memory that we're going to free is on the, let's see. It's the image memory, right? And of course, here is the allocator, so context allocator. Right? So we free the memory there. We should probably also report that memory, right? So how we report this here, we should also sort of unreport it, right? Or report it as being freed. So we can do that up here. So we'll say k free report, right? And that basically just undoes that operation. So we destroyed the image, we destroyed the memory. We unallocated or unreported that. Next, we have to destroy the image views themselves, right? Which is basically just undoing this stuff, right? So I'm just going to actually copy pasta this. So if image has view, then we don't actually need to do that. We just need to vk destroy image view. And what does that want? I think that wants the device, the view, and then the allocator. So device, we don't need this. And then for some reason they switch this, the order of this, in the free to have the allocator be last. I don't know why they did that, but there we have it. Right? And there's no vk check because that is return type void, so there's nothing to check. So we free that one. I think this one, let me check something here. Vulkan set debug object name. I don't think there's any way to unset that. No. Okay. All right. So we don't have to worry about that. This can just go. And then destroy views per layer. So if we have more than one layer, then we go through those. And we say vk destroy image view. we get rid of the create infos, take this, put it here at the end. And then get rid of the VK check because that is return type void, right? Okay. So we destroy the image, we free the memory, we report the memory as being freed to the memory system, then we destroy all the views. Now we're ready to create the new. Cool. All right. So that will help out our resizing logic by quite a bit. Let's see. Guy Janowski, hello. Welcome to the stream, first time chatter. Hello, can you make a YouTube video for noobs to show how to study the engine code? So studying code is actually, that's something that's kind of difficult to teach how to study code. And the reason I say that is because everybody has to do it differently. So the issue with that is some people are more visual. Some people can just read things and figure stuff out. Some people actually have to get in there and actually write code to figure it out. I'm one of those people, right? And so I could create something like that, but the problem is it wouldn't necessarily be beginner friendly for every type of learning style out there. So it's actually kind of difficult to create a video to tell you how to study because that differs so widely for everybody. But what I could do is offer a little bit of advice on how to, or maybe what to look at, what to read, and start from there. Because I will say this, right? If you are just beginning, whether you're just beginning in dev, whether you're just beginning in game development, what have you, I don't know where your skill level's at. If you were to jump in and try to examine the source code of Unreal Engine, you will get overwhelmed, guaranteed, right? You have seasoned developers that have been working on stuff for a long time that would get overwhelmed by that code base, right? Game engines are huge, right? There's very, especially commercial game engines, like there's very seldom somebody who understands the entire thing. Yeah, Unreal code is a mess too. Yeah, there is that. And of course that happens anytime you have large teams of people working on anything. It eventually becomes a mess, right? There's not really much you can do about that. You just have to do the best you can. What I will say though is if you're interested in learning how game engines work, how they are organized, and so forth, I would say understanding the concepts at a high level is going to help you out the most at first, right? You can just jump into the code, but unless you have an understanding of what that code is supposed to be doing, and what it's targeting, and the underlying concepts of what it's actually accomplishing, the code's not going to really make any sense, right? That may not even be the right place for you to start. So, I punt this book a lot, but this is a book that I recommend that anybody that is looking into game engine development reads. It's called Game Engine Architecture, and it's by Jason Gregory, right? And this is the 3rd edition. It's a thick boy, It's at least two C's thick, I would say. Maybe even 3 C's thick. I have tons of bookmarks in here, right? But the reason I recommend that book is because it is a high-level primer on lots of systems and how game engines are sort of composed from a high level. It does touch on some programming things, some memory management, processor, multi-threading, that kind of stuff. It touches on some of that. But the most valuable part of it is that sort of high-level bird's-eye view explanation of how game engines are architected, and some of the differences between different game engines and things like that. This one mostly focuses on the engine that Naughty Dog uses, but it's also a great example of a way of doing things. And so I always say pick that book up as a starting point, right? and then kind of go, yeah, you're familiar with the book? Okay. You tried to step into some game code with a debugger, and it wasn't very helpful. So that's exactly what I'm talking about, right? Because those code bases are so huge and they do so much that unless you understand what all those systems are trying to do, where the hell do you even put a breakpoint to try and understand it, right? There's no way that you're going to logically be able to understand all of that stuff. And so generally what I say is, start with something like this book. There's also real-time rendering, which also explains a lot of rendering concepts. Look at examples online. There's Vulkan examples online that like Sasha Willems put together. I actually brought this up earlier. Do I still have the tab open? I do. So this repo is really good. GitHub.com Sasha Willems Vulkan. If you're interested in Vulkan specific stuff, that is very good to look at because it's rendering specific stuff. That doesn't really, it's not an entire game engine, right? But that's a good place to start as well. There's tons of tutorial websites out there that you could look at as well that might help you understand this stuff. There's like Learn OpenGL if you want to learn OpenGL. So Learn OpenGL is probably going to be a good one for you, right? And that will at least teach you about the rendering aspect of it. And then you just kind of learn one system at a time, right? Learn about input, learn about file management, file system management, learn about windowing, learn about dealing with sound and stuff like that, right? And just kind of take it one bite at a time. Don't try to understand the whole thing as a huge, gigantic picture all at once. Take it a bite at a time. If you want to learn by reading code, download a Git client. I recommend Fork. Get the source for Kohi and check out the old commits. Yeah, that's another way to do it. Because this engine that we're building here, we've built almost entirely on video. There are some things that I did later on off camera. But we literally, I recorded the process even of creating the repo, right? So from engine code, line of code 1, we kind of started that. And that was one of the reasons, right? Is because there isn't really much out there that does that. So that's one of the reasons that I created that. Not to sort of plug my own stuff, but there's lots of resources out there, and those are just some of them that you can look at. Cool. I'm glad you find them useful. Okay. Yeah. So I would recommend just watch through those. It starts off as a tutorial, but we eventually did have to move away from that because the code base is just too big now to really have it work in a tutorial format. And so we've kind of moved away from that to live stream formatting, which I think makes a lot more sense because I can spend more time programming and not a whole bunch of time editing videos, right? And you guys can also see my thought process behind things as I'm writing code, why I'm writing what I'm writing, what I'm thinking, because I also try to do a brain dump as I'm doing this, right? So I hope all that makes sense. All right. So we kind of went down the Vulkan image recreate rabbit hole here. But I think... Why is this bleating about is device memory? Oh, because we already did that check up here. Okay. We can nuke that. Okay. So now my question is, so we have some of these things like our image memory flags needs to be cached off, right? Name needs to be cached off, but like I don't think we need things like the dimensions, MIP layer count, stuff like that. I don't think we have to hold on to that stuff because a lot of that stuff is actually stored in the creation info that we're saving off. So I think we'll be okay not doing that. So what I mean by that is all of these things, right? Memory flags I know is one thing we have to keep, but like we have the width and height at a higher level. I don't know that we need them here. So we may want to come back and like remove some of that stuff. Oh, we have layer views. We need out image, layer view create infos. We need to zero that out as well. Oh, did we not also do... We didn't do this one either. Make sure those are zeroed out. Okay. So I'm not going to change that for now, but... let's see. So we have the image view creates. Image view creates, which I don't think we actually need anymore. So we'll do Vulkan image view. Wrong search. Vulkan image view create. Yeah, so that function is not used anymore. So that also means that we can make it go bye-bye. Right? Because we don't need to do this anymore. It's just kind of handled for us. We do need to, however, take this. We do need to take this. Let's see, and put that here. And we'll say destroys and recreates internal image and view resources based on current create infos which are cached on the provided image. If changing properties, i.e. resizing, modify those create infos first, right? And then we'll do param context. Actually, we can just do this, right? And then pointer of the Vulkan context, a pointer to the image to be recreated. Okay, so now that's there. We should also take this static assertion and move it up to near what actually uses it, which is right here. And we don't use the Vulkan device H anymore. And let's see, do we have any more? No more warnings or anything in this file. This file is good to go. Okay, so all of that to circle back to over here, where we are, where we're resizing and really just destroying the old image and creating a new one, right? We don't need to do that crap anymore. So what we can do is, instead of calling all of this, we can now just call our recreate after changing our size, and we should be good. Observer Herb steps into the brain dump. I love it. Diamond, good to see you. How's it going? Started working on an interpreter in Zig, and it's been really fun so far. Parser work is ongoing. You really like Zig. Yeah, I want to try Zig at some point. My fear is that I'm going to like it too much and then hit some critical bug. That's going to be super annoying. Because it's a fairly new language. And if I hit a language bug, I'm screwed in terms of this project, right? So, I want to try it, maybe, but I can't bring myself to do it yet. But it looks like an awesome language. I want to check out Odin as well. Okay, so I think what we should just do here is we have, so we're resizing our internal textures, right? So we should be able to do, we need this, right? So we should be able to say image create info, extent width, and that's going to be, what did we do? New width, new height, I think. Yeah. So that's going to be equal to equals new width and height equals new height. You moved from Make to Zig to build your engine. That's not a bad idea. Although the only part that sucks about that is like I don't want the extra dependency, right? I'm trying to like be as dependency free as I possibly can. You can write and build your DAG in Zig. Yeah, I mean, that's true. That is true. If I ever do switch to one of those languages, like it'll be all in, right? Like I actually plan on removing Make as a requirement for this because I'm going to write my own build system at some point. I just haven't done it yet, but yeah, that's coming at some point too. I basically want the only requirement of this to be the C compiler in Vulkan, right? Or DirectX or whatever it is you're using. Okay, so if we have that modified, we should probably recap or recalculate MIP levels. Right? So, if image MIP levels is greater than 1, then image MIP levels is that. And then we should be able to do Vulkan image recreate, pass through context, and pass through the image. And that's it. So we should actually be able to get rid of all this stuff now. Bam. Much simpler, right? So all we have to do for this is just modify these sizes, recalculate how many MIP levels are going to be there for that size, right? And then just pass through the image to say, hey, recreate this with the new size, and it's done. Claude Van Dort, hello, welcome. Fuzzard9999, thank you for the follow. Claude, thank you for the follow as well as Wubbalub4. Is that like a dubstep reference? Wubbalub? Is that like Claptrap's dubstep? Wub wub wub. All right. Jeet, thank you for the follow. Appreciate that. All right, so that fixes our texture resize, which is pretty sweet. Now we have the image format thing to deal with, which actually we don't even need to. We can actually just say what was it? Texture data. Or no, it's image format, right? Okay, so current frame is connected to the current window that we have. So we're gonna have to get that because the current frame does not exist. Also, the staging is part of the current window as well. So, because we've moved those things, that's why that's bleating at us. This should also be back end. And then we have ads. My keyboard, you know what? I'll answer the keyboard question after ads. That way I can give you a better answer without the ad screen there. But yes, I will answer the keyboard question there in just a minute. Yeah, Vulkan, yep. Six ads, yeah. That's why I paused the stream. Almost done with ads. All right, ads are dead. So, for those of you who are new to the stream, since this is a programming stream and what we're discussing here is fairly technical and detailed, whenever ads come up on the Twitch side, at least we do simulcast to YouTube and Twitch, but whenever ads come up on the Twitch side, I like to pause the stream because we're served with ads once every 30 minutes for up to 90 seconds, depending on region, locale, and platform, right? And so I like to pause that so that nobody misses anything, right? Because some people get 6 ads, as Nathir mentioned there, but some people don't get any, right? But I want to even the playing field and make sure that nobody misses anything. So we pause, we put a timer up on the screen so that you can see exactly how long we've got until we come back. And I usually say, go ahead and hydrate during those ad breaks. Go get some water if you need to, because I won't continue working on things until that comes back. So Chunky Lover mentioned the keyboard, which I actually need to put a keyboard command in there to answer this question, but I'll answer it manually now as to what keyboard I'm using. So I'm using the, hold on, I've got my cable management going on here. So I use the Keychron K2. Is it in frame there? There it is. And this is the 65% version, right? So it's got the full keyboard here with all the F keys and all that. It's got the arrow and the home page up, page down, things like that. Really like this keyboard a lot. It's got the brown switches in it, this particular one. Great keyboard. Best keyboard I've ever owned, honestly. I've had a lot of keyboards. I've gone through a lot of keyboards over the years. And this one is by far the one I like the most. So yeah, I probably ought to put a keyboard command in there for sure, so that exclamation keyboard works. But yeah, I hope that answers your question there. And so yeah, we are doing Vulkan here. So basically, we're in the middle of a fairly large refactor where we've moved around a lot of stuff. And because we've moved some stuff around, that's why we have sort of the errors peppered throughout our code, and we're just fixing those things. So Kello's Music, hello. How's it going? I recognize the name. I don't think I've seen you here for a while. Count Digi, thank you for the follow. I appreciate that. Kev Burns Jr., how's it going? Yeah, there is no keyboard command, unfortunately. I'll get that added. But yeah, it's a Keychron K2 is what I'm using. You bought a glove 80 a couple months ago. Best investment. My hands love me. Yeah. So I don't know. I don't know how I feel about the split keyboard thing. And the problem is I can't try one without having to buy one, right? And I would hate to spend that kind of coin on something that I then wind up hating. So this one is great because it actually is a wireless variant of it. So I can use it with multiple machines at one time. It's got 3 Bluetooth connections that I can switch back and forth, or cabled, which is what I use on my desktop. I really like this one a lot. It's very comfortable to type on. Yeah, so I use this one all day, every day. I use it for both work and in here streaming. You've lurked here a few times. You can only keep up for so long. That's fair enough. Yeah, I was gonna say I recognize the name. So, but yeah, welcome, and it's good to see you. Yeah, you took a leap of faith because it was either that or quit typing. Oof. Yeah. I hope I never hit that point, but if I do, I suppose I'd have to take a leap of faith there too. I love the work that you do, but there's a limit to how long I can pretend to follow along. That's fair enough. I mean, some of the stuff we do here is pretty intense, right? Smudge, that's your favorite feature of the keyboard, wired or wireless, 2.4 gigahertz dongle or Bluetooth. Yeah. This one is just Bluetooth. It doesn't have the 2.4 gigahertz, but it's fine by me. The Bluetooth works just fine. So like when I switch to my work machine, it's right there. It doesn't have to go very far. But I can also use it with the Mac, and I don't have to like reprogram it or repair it every single time. It could just switch back and forth. It's pretty sweet. Using an NJ80. Need another one for the office. Maybe I'll get the K2. Yeah, I highly recommend the K2. It's a great keyboard. It feels great. It sounds great. It's very easy to type on. It's not too chunky, I feel like the resistance is just right as well. But it can also take a beating because I'm kind of hard on keyboards, I think. All right, so we have a number of issues to fix in this file, and we're not going to get through it tonight because, speaking of work stuff, I do have to get up in the morning and I do have to work. So I think we're right at about the end of time here, so I'm going to wrap up the stream now, I think. And I'm going to try and get a little bit of this refactoring, mostly this stuff around the things that have moved around. I'm going to try and get some of that stuff done off camera so that we can kind of move this forward and get this refactor effort done, right? Because we've been working on it for a while, and I kind of want to get moving on and start creating a game, right? That's the goal. So, yeah, I think that's where we're going to leave it for tonight. Let me just catch up with chat here. Bluetooth is wonderful for the convenience, but I perceive a little delay for gaming. So I'd like having the dongle option as well. Yeah, I would not game on Bluetooth for sure. And that's the reason that that I use the hardwired connection on my desktop, because that's where I game. Yep. Started learning C# since the last time we talked. Okay. Aside from your time learning Godot script. Okay. Yeah, C#'s a great language to learn. There's lots of uses there. There's even Monogame that you can use to develop games using C#, right? So that's a fantastic resource. Stardew Valley was written in that, actually. So, definitely that's an option, right? I've written games using XNA back in the day, which was that became, well, not became, but Monogame sort of replaced that. Same for Terraria. Yep. So it's definitely something you can use. Absolutely. Still trying to keep my focus on things relevant to audio rather than trying to build entire games. That's fair. Terraria was XNA, then they moved to Monogame. Yeah, a lot of people had to do that when they killed XNA. Yep. At least to the extent it's possible. Yeah. That's fair enough. All right. I'm going to look for somebody to raid. Let me see what is going on out here. I'm just going to take a quick look. Let's see. So, speaking of Godot, I am going to raid a channel that does. He's actually working on like a retro FPS in Godot, and it's a pretty neat project. So this is what we're gonna go with. We are gonna raid Jitspo tonight. He's a cool dude. He's made some pretty awesome stuff in Godot. So definitely ask him about his game, and ask him about throwing books at things. And he'll show you something that he put into his game as kind of a joke, and it kind of became a little bit of a meme. But yeah, definitely I would suggest giving him a follow as well, because he's he's pretty entertaining to watch, and he makes some pretty cool stuff. So, all right, that is where I'm going to end it tonight. Thank you guys so much for joining me. If you haven't already, I would really appreciate any follows, either on the Twitch side or the YouTube side. They help me grow the channel a lot, and I really greatly appreciate those. So, yeah, with that, I will see you guys next time. Have a good one.